All right, the periodic table. Periodic means repeating pattern. When you think of periodicals, I don't know if you know what a periodical is. That's like magazines and newspapers. Those are called periodicals. If you go to the bookstore and say, where are the periodicals? They'll send you to the magazines. Why? Or the newspapers. Because they come in repeating patterns every month, every week, every day. So when we call the periodic table, that is because they're trying to find periodic or repeating patterns for the chemicals. In the 1800s, a Russian physicist named Dmitry Mendeleev was the first one to come up with a usable periodic table. Other people had tried to organize the known chemicals or the known elements at the time, but were not as successful as he was. He took all of the known elements at the time, and there were about 64, I think, and he arranged on index cards. He wrote down all of their properties, chemical and physical properties, and then he tried to figure out how to arrange them so there would be some sort of repeating pattern, some sort of way of using it. And he ended up arranging them by their increasing atomic masses. So he would order them from left to right by increasing atomic mass. And if you look at the periodic table, the atomic mass goes up with the atomic number pretty close. However, when you get to like potassium and argon, I think, they swap. So potassium would have been where argon is, and argon would have been where potassium was. And so he had these problems every now and then. It would be like all of them going down a group would be very similar, and then one would be totally different from the others, but he didn't know how to fix it. So it stayed like this for like 50 years. But what he did do is he would leave blanks for unknown elements or elements that they had not discovered. And he would predict that they would find an element that would have this mass and these properties. And he did. And they were right, because after he died, they actually discovered these new elements that fit right where he had left those blanks. The first one was gallium, and it had all the characteristics of that one that he had put in, that had left blank for gallium. And it was about 50 years later that Henry Moseley came through and rearranged the periodic table according to atomic numbers, increasing atomic numbers. Those inconsistencies that were there finally disappeared. This is how the modern periodic table is arranged today, by increasing atomic number. And Henry Moseley is the chemist, actually. He was an English chemist that came up with this. Here is a periodic table showing the staircase going down the middle right here. And that separates the metals on the left from the non-metals on the right. Everything touching the staircase, except for aluminum, is considered a metalloid. So just as a recap, metals on the left of the staircase, non-metals on the right. Touching the staircase are your metalloids, except for aluminum. Now also on the metal side, hydrogen is hydrogen is a non-metal as well. When looking at the periodic table, there is a staircase that goes down the right side of the periodic table, and it separates the metals from the non-metals. Everything touching the staircase is considered metalloids, and metalloids are somewhere in between metals and non-metals. Metals, everybody knows what a metal is. You take iron or steel or aluminum, for instance. They're shiny, they are malleable. Malleable means they can be banged into sheets or moldable. Ductile, they're ductile. That means they can be drawn into wires, kind of like copper wires. And they are good conductors of electricity. So everything on the left side of the staircase, except for hydrogen, is a metal. On the right side of the staircase are your nonmetals, and they are just the opposite of metals. They are not malleable. They're brittle. They will break apart. They are not ductile. They are not good conductors of electricity, and they are dull or not shiny. So now metalloids. The only one that's touching the staircase that is not considered a metalloid is aluminum. And aluminum, as you know, is a metal. The other ones are all metalloids, and they might be, let's say, dull looking but good conductors of electricity. So they're somewhere in between your metals and your nonmetals.